Hi, I'm here with Don Reinertsen. I'm Jesper Bøck from Trifork, and we're at the GOTO Copenhagen 2012 conference. Welcome, Don, and thank you very much for being here. It's an honor.
I'm glad to be here.
Good. And of course we have some questions for you, especially related to your book and your work in general. The first one being, your book, Principles of Product Development Flow, is by many considered the most important book in the Agile space in the last 10 years. Yet Agile is barely mentioned. Has this product market fit come as a surprise to you?
It didn't come as a big surprise to me in that, I can remember talking back many years ago at a OOP conference where I was talking about the lean DNA of Agile methods. And so I sort of recognized the presence of there's some shared DNA in both of those spaces. So I would have had a hypothesis that some people in Agile would be interested in some of the things I was saying. I guess it was a stronger response than I would have expected, and I think it more reflects the fact that in the Agile space, a lot of the methods are empirical and faith-based. And I think there were probably people hungry for a little more scientific approach to doing it. And I think it filled a little niche within the Agile space.
Okay. And it seems that though many books like yours have dealt with the topic, maybe not in such a scientific way, but still we've got fixed price contracts, we've got batch budgeting, we've got phase gate models and big bang releases all over the place. Why is this still such a big problem when so much theory states differently?
That's an interesting question, and one that I've had to deal with for about 25, 30 years now. I think there is still a lot of belief in the idea of large batch sizes in processes. If you look at a lot of the traditional doctrine for how do you do development is very much anchored in these stage gate process ideas. The idea that if I don't do something until I have all of the information necessary. I don't start something till I have all the information necessary to complete it. You just see, for example, a traditional PERT chart will be based on any precedence diagram that uses the concept of strict precedence says I don't start an activity until I have all the information or the stuff ready to complete that activity. And that has so permeated management thinking that it seems quite natural that I should not start design until I have identified 100% of the requirements. Because I will need 100% of requirements to finish the design.
Do you think this is an intuition we're born with, or is it our schools, our educational system? How do we get...
No, I think it is actually, we get educated into thinking the wrong way. Is that I don't think it's intuitive, because if you look at, for example, most engineers who either start tinkering with hardware or tinkering with software and things like that, if they have no training at all, their natural tendency is going to be work in small batches with fast feedback. That is anytime you've tried otherwise, where you try to bite off too much work and you discover it doesn't work, and then you have to find out why it doesn't work, you instantly get feedback from the universe that large batch sizes are bad. You have to be educated to start thinking that large batch sizes are good.
So it's a usual story with the small team that rediscovers Agile because they grew to a large organization and then they stopped doing all the common sense.
Yeah, well, if you look at the original where the term hacker came from in terms of the hackers at MIT, that the hacker club at MIT and things like that, is that, you know, the basic traditions of engineering sort of go back to making a small change at a time and looking at what the consequences are and building on that. So that small batch size approach is very natural. It's just you need to also make it permissible in an organization.
But other things that are less common sense, like for example what we're usually struggling with is the fact that not loading people to 100% seems to go almost against intuition or common sense.
Yeah, no, I think you're absolutely right. There are certain things that make a lot of sense for people to use small batch sizes that you don't really have to change mindsets for. There are some other issues that are extremely alien to a lot of managers, and one of them, for example, being the notion that if I load to 100% utilization, I will actually get worse outcomes than if I load to a lower level of utilization. You know, because people's natural intuition is the busier my people are, the more output I will get. And they tend to think that if engineers are busy 100% of the time, that will raise the output of the organization. And what they ignore in that calculation is that when people are busy 100% of the time, the queues get very large in the process. The queues delay feedback, and delayed feedback hurts efficiency. And so while you're under the illusion you have an efficient process running at 100% utilization, is that you don't have an efficient process at all. And one of the other intuitions that people are very bad with is the idea that a lot of people start more stuff than they should and have too much work in process. And it's because, again, there's sort of a natural feeling that the sooner I start, the sooner I'll finish. So therefore, if I have any spare time at all, if an engineer becomes free for 15 minutes, I ought to put them to work on doing something.
But how do we change this? It's taken, like the manufacturing context, 30 years to realize that, and they're dealing with repetitive processes where they can see the physical stock in the warehouses, and even they have taken this long to accept that it's not.
No, you're absolutely right. Is that, you know, the key to the solution is to eliminate inventory in the process, not having too much work in process inventory. As you say, in manufacturing, the WIP is physical objects. You can see when you have too much inventory, and the WIP is carried on the balance sheet, as you know, because we can capitalize work in process inventory in manufacturing. So when you reduce inventory in manufacturing, management says, this is great, I just got $2 million of free cash in this process. In development, where WIP is carried at zero value and things, you can't show the benefit of reducing inventory financially. You can't physically see it. So, sad to say, I think it's going to be a more difficult problem making people conscious of WIP in development than it has been in manufacturing.
So we're talking 60 years?
Yeah, well, I don't want it to be 60 years, but hopefully we can build on the experiences that they had in manufacturing.
So along those lines, I guess we agree that a product development context is a context where there's a lot more variability than we deal with in manufacturing. The fact that we have this uncertainty all around us, is that really the heart of Agile, and maybe also the reason why your book has penetrated the Agile space in the way it has?
Yeah, it might be, because I was just observing last week at a conference that I believe people in the Agile software space are doing a better job at using Lean in product development than companies that have 40 years of experience with Lean manufacturing. And that's because most of the lean manufacturing people have this toxic idea that variability is always bad and that it is feasible to eliminate variability. And in highly repetitive manufacturing processes, there's some truth to that, and in manufacturing processes, you don't need to innovate. In product development, you need to innovate in order to add value and things, and as a result, if you try to drive out all of the variability, you drive out all of the innovation. And so I tend to feel that, you know, you go back to the original Agile Manifesto and things, and there was an acceptance of the idea that you have to respond to change, you have to deal with variability, and the people in the Agile software space are not in denial on that issue, whereas the people in lean manufacturing have tended to believe it worked so well in manufacturing, it should also work well in product development. And they're just beginning to discover that it doesn't work well in product development.
Are you saying that Toyota, which is used as a model for good product development processes, that they're really behind some of the things going on in the software space?
Oh, I'd say Toyota is way behind what's going on in the software space. And, you know, I often, people will tell me Toyota is an innovative company. And I'll ask them, I'll say, well, identify 3 innovations that have come out of Toyota. And they'll say, well, there's the Prius, and there's the Prius, and there's the Prius. It really, they can't come up with examples. Occasionally, they will mention the Lexus, maybe without realizing that that Honda was introducing the Acura in the United States years before Toyota did. Honda was really the first company to rebrand you know, their brand as a high-end brand. Most people are not really aware that the Prius was not the first introduction of a hybrid car, but there's a very limited amount of innovation that is present in Toyota's process because of this huge focus on reducing variability. And you often see it actually in how innovative their cars are in terms of, do they get share within the market when they're competing against cars that have, you know, more advanced designs. So, you know, I think I was talking with some folks about the penetration of the Lexus in Europe, and the Lexus hasn't done nearly as well in Europe against Mercedes and BMW as it did in the United States.
So the fact that people are almost treating Toyota, because of their success with the lean manufacturing approach, as someone to copy in the product development space, is that a real challenge we have to face? Because we all know that there's a lot of book outs there stating how brilliant Toyota is doing product development, and how they use multiple development of the same item to try to make sure that variability is at all costs eliminated.
Yeah, I think that problem's going to go away, because eventually the people who read about Toyota's the best company in the world are going to end up getting a Toyota financial statement and looking what their actual performance is. And then they will end up discovering that Toyota's performance is below average when compared to a large population like the S&P 500. It's not even a question of being in the top 30% or the top 20%, the top 10%. It's that it's in the bottom half.
Okay.
So, you know, people will eventually do a little reality testing with data, and then they'll start whispering, as Hans Christian Andersen did, the emperor has no clothes, right? But we haven't reached that point yet.
No. So debate between you and Jeffrey Liker would be...
Yeah, sooner or later somebody's going to mention that the emperor has no clothes.
Good. For me personally, and I've been through your book at least 2 times, plus all the times I've just looked through it. It seems incredibly dense, and before I started you warned me that this was not supposed to be an easy read, and though very valuable, it definitely wasn't. How come? Why was it not purposely meant to be an easy read?
Well, I'll just tell you that, I mean, the practical consideration, which is that if you ended up writing a 600-page book, people would not read it. You know, 300 pages is about the maximum that people are going to pick up as being I'm going to undertake this book on speculation. The book was coming out 12 years after I wrote the previous book, so there was a lot of accumulated stuff to cover. And I didn't really believe in the strategy of writing 2 300-page books, you know, part 1 and part 2. I'm not sure that works. So what I opted for is I just said, look, let me just increase the density in the book. There will be some readers who value that, and you know, I wanted to write a book that people would open more than once.
Okay.
And
so we won't see Principles of Product Development Flow for Dummies coming out anytime.
Well, actually, I think there's a need for that, but you know, I sort of someday what I want to do is just write a 150-page version for non-engineers, and just covering a couple of the ideas, because that will save time for people who have read the whole book, not having to explain personally every idea in the book to the other people in their organization. So that's on the agenda, but there's no forecast date for when I'll have that.
Speaking to David Anderson, you get very much the impression that that you are responsible for convincing him to try out implementing Kanban systems in software. How do you see your work and David's work fitting together on a larger scale going forward?
I think I've got enormous respect for David's work. I mean, the one reason why I wrote the foreword for his book Kanban is I really did feel it was that worthwhile that I wanted to invest my effort in it. I think his thinking is constantly evolving and progressing. If you'd asked me about David, you know, like 10 years ago, I'd say, oh, he's really done a great job with cumulative flow diagrams and things. Is that, you know, he's gone beyond theory of constraints and now moved to cumulative flow diagrams, and you know, now I'd say he's recognized the value of some of the Kanban, the whip constraining ideas that are present in lean manufacturing, and massively, when I first visited him and I explaining he was using a Kanban system, I pointed out to him, I said, you know, you've gone way beyond what a Toyota Kanban system is, because a Toyota Kanban system will basically have a whip constraint that ends up blocking work when you hit a certain level, and it will process work in a first in, first out basis. And that was what the time when he was starting to introduce classes of service in the Kanban. And you know, there's no classes of service being used in manufacturing Kanbans, and manufacturing hasn't really dealt with the issue of non-homogeneous delay costs, where some jobs have higher delay costs than others, and that will cause you to want to use sequences different than FIFO sequences, first in, first out. So I think he's done a great job of taking those ideas and transforming them into something useful in product development, and I absolutely think he's going to continue to develop a lot of great new ideas. I think we haven't heard the last from David Anderson.
Could you just very quickly elaborate on the difference between GOC and the Kanban system? I think that there's a bit of confusion in that area where some see GOC as maybe just another version of the Kanban system.
Well, and there's probably a reason for that, because TOC is also a whip constraining system. You can view Kanban and TOC as both being in the family of whip constraining systems. They're not the only systems in the family, but they are certainly the most prominent ones. The TOC system, because Goldratt says you want to let work enter the system at the operating rate of the bottleneck, the whip constraint in TOC is the global whip pool ahead of the bottleneck. The whip constraint in a Kanban system is the local whip pool between two adjacent work centers. And so what Kanban does is it constrains all the local whip pools, and if you constrain all local whip pools, you've got a global constraint, right? And the TOC is constraining the pool ahead of the bottleneck as one big pool, and that choice of being a local versus a global whip constraint is what produces the performance differences in those two systems. The TOC system turns out to be quite good when you have a relatively persistent bottleneck that is immobile. It stays in the same place and things. And so there are classes of product development problems for which that works quite well. The Kanban system is a very elegant solution to the problem of temporary bottlenecks, where the bottlenecks develop and then they go away, or mobile bottlenecks, where a lot of times you can describe product development as being like the bowling ball traveling through the boa constrictor. Is that, where you progressively overload different stages of the process. And the nice thing about a classic Kanban system is it makes no assumption about where the bottleneck is. It intrinsically responds to emerging overloads of hitting upper limits. It then downregulates upstream processes. When you regain capacity, it upregulates them again. So it's very adaptive to variable bottlenecks.
Yeah. So you could easily say that a Kanban system is much more effective in a context like product development, where the difference would be less in manufacturing, which is probably also why the goal now is mandatory reading at Toyota, since he translated into Japanese. I read.
No, that would make sense to me. And I would have to go just empirically. If I look at the companies I work with, I'd say I would probably see 15 or 20 instantiations of a Kanban system being used in product development for every instantiation of a TOC system. A TOC system is still out there and it's still working for a lot of people, but I think the Kanban systems are actually flourishing much faster than the TOC systems.
Okay, I think we're reaching the end of our 20 minutes. Any last questions, topics you think we need to cover before we close this up?
No, I don't think so. It's been an enjoyable conference here so far.
Good. Thank you very much for participating.
Okay, thank you.